In this problem, you're going to learn how to calculate equivalent annual cost or cash flow. Vandelay Industries is considering the purchase of a new machine for the production of latex. Machine A costs $3.1 million and will last for 6 years. Variable costs are 35% of sales and fixed costs are $204,000 per year. Machine B, on the other hand, costs $6.1 million, but it will last for 9 years. Variable costs for this machine are 30% and fixed costs are $165,000 per year. The sales for each machine will be $13.5 million per year. The required rate of return is 10% and the tax rate is 35%. Both machines will be depreciated on a straight line basis. If a company plans to replace the machine when it wears out on a perpetual basis, which machine should you choose? Since the keyword is they will replace it on a perpetual basis, that's why we cannot look at the net present value. To compare the projects, we need to look at the equivalent annual cost or cash flow, which means we calculate the present value for each of these projects, the net present value, then find the equivalent annual cash flow for each of these. Now, first, let's calculate the cash flow from assets for both machines. Start with the depreciation. Take the initial cost, divide it by its useful life. Same thing here. Calculate the net income, which means annual sales minus fixed cost minus the cost percentage times annual sales, which is the variable cost, minus the depreciation, times 1 minus the tax rate. So machine A will have a net income of 5.2 every year, machine B 8.6. Of course, we need to add back the depreciation. Now for each machine, we have the initial cash flow of $3.1 and $6.1 million cash outflows. Then for each year, let's fix the row numbers. There is no salvage or net working capital here. We don't have to worry about it. And the net present value is simple, using the discount rate. Plus the initial cost. So the first machine, actually, I did kind of a boo-boo. The first machine actually has cash flows for only 6 years. And the second machine will have for 9 years. So let's correct this formula. Even though if you have blanks, it will treat them as zeros. I like being thorough. So the first machine had a net present value of $22 million, $22.7 million, and machine B has a net present value of $49.5 million. However, machine B is producing income for 9 years. Machine A is producing income for 6 years. So a direct comparison is not possible. What we need to do, calculate the equivalent annual cash flow, which means find the payment for an annuity that has a present value of $22.7 million. That's our rate, discount rate. Number of periods is 6. And present value, we put a negative in there to produce a positive number. So if we had an annuity that produced $5.06 million plus some change every single year for the next 6 years, it would have a present value of $22.7 million plus change. Similarly, all I have to do is copy this one. Let's make sure that we're reading off the right numbers. So the first machine produces an equivalent annual cash flow of $5.06 million, and the second machine $8.26. Well, since the second machine produces a higher annual cash flow number that has a present value that is same as the entire project, we actually picked the second machine.